Lecture 4, 4.4 System of linear equations with three variables. At the end of the lesson, students should be able to write a system of linear equations in the form of ax is equal to b and solve ax is equal to b using inverse matrix. You have probably familiar with linear equations such as y is equal to x plus 4 or y minus x is equal to 4. These equations in graph will give you in a straight line. A linear system, then the collection of linear equations. Our usual linear equations have only two variables because we have two variables. A linear system using this kind of equations will have two equations. But did you know that you can also have a linear system with three variables? Yes, you can. A linear system in three variables then will have three equations. Such it have three variables. These equations, just like the one with only two variables, will not have any exponents. This is an example of linear system with three variables. Looking at the system, we can see our three variables, which is x, y, and z. These three letters are the most commonly used, although you can use any letter that you want. They don't have to be in order either. An equation such as x plus 2y plus z is equal to 9 is called a linear equation in three variables x, y, and z. Any ordered triplet x, y, z that satisfies an equation is called a solution of the equation. For an example, 4, 2, and 1 is a solution for x plus 2y plus z is equal to 9 because when we insert the value of 4, 2, and 1 into the equation, we get the total value of 9. A system of linear equations in three variables can be consistent or inconsistent. A consistent system of equations has either a unique solution or an infinite number of solutions. An inconsistent system of equations has no solution. This is the form of a system linear equations, which can be written in the form of ax is equal to b, which A is a matrix coefficients with 3 times 3 format, and x is the matrix of variables, and also B is the matrix of constants. Example 1. Write each system of linear equations in the form of ax is equal to b. Given to you two questions, which is A and B, in the form of linear equations. After that, make sure that you know which are the constant and which are the variable. The variable involved is x, y, and z. So from the linear equations in the form of ax plus b, just use all of the value which is located at the linear equations and form matrix A 3 times 3, and then matrix X, which is x, y, z, and matrix B, which is 11, 3, and 9. Also same for question B, we have 4x plus 7y plus z, and then x plus y minus 5z, and then 2x minus 3y plus 8z. Form a matrix A and then a matrix variable and also the constant, and it will become like as stated in front of you. Okay, and then for example 2, this is more on problem solving. Okay, a restaurant sells 3 types of Western food, namely chicken chop, fish and chip, and lamb chop. The price for one lamb chop is twice the price for one chicken chop. A family paid 64 ringgit for 2 chicken chops, 5 fish and chips, and 1 lamb chop. Another family paid 82 ringgit for 3 chicken chops, 2 fish and chips, and 4 lamb chops. If X ringgit, Y ringgit, and Z ringgit represent the price of 1 chicken chop, 1 fish and chip, and 1 lamb chop respectively, obtain a system of linear equations in the form of ax is equal to b. In this question, it asks you to form linear equations. First, you have to determine the variable involved, which is x, y, and z. Okay, 1 chicken chop for x, 1 fish and chip for y, and 1 lamb chop for z. All are in price. And then stated that the price for 1 lamb chop is twice the price for 1 chicken chop. That means the 1 lamb chop, which is represented by z, is twice price for 1 chicken chop, represented by x. So we can make a first equation, which is z equal to 2x, or we can make it as 2x minus z is equal to 0. This will represent as equation 1. So for the next information, given to you the price for 2 chicken chops and 5 fish and chips and also 1 lamb chop. If we make it the equation there, we will have 2x plus 5y plus z is equal to 64, which is represented by equation 2. And also the price for 3 chicken chops, 2 fish and chips, 4 lamb chop, and we make the third equation, which is 3x plus 2y plus 4z is equal to 82. So we combine all the 3 linear equations and make it a system, and we can write it as ax is equal to b. So it will become matrix A, which is 2 0 negative 1 2 5 1 3 2 4, and the matrix variable, which is x y z, and the matrix for constant, which is 0 64 and 82. Then another example, we can solve this example, which is stated the nutritional content in gram per serving of protein, carbohydrates, and fat for 3 types of cereal is given in the table below. Okay, under a controlled diet, Nurul took exactly 54 gram protein, 620 gram carbohydrates, and 21 gram of fat in a particular week. In the week, she ate X serving of cereal X, Y serving of cereal Y, and Z serving of cereal Z. And then the question asks us to form a system of linear equations in X, Y, and Z terms, and also write the system of linear equations in the form of AX is equal to B. And then we already know the variable involved, which is X, Y, Z, which is X is the number of serving of cereal X, Y for cereal Y, and Z for cereal Z. Okay, the first question, we have to form a system of linear equation in X, Y, and Z. Okay, so referring to the table, directly you can get the linear equation involving the three variables, which is 2x plus 3y plus 4z is equal to 54, 20x plus 30y plus 50z is equal to 620. This is for consumption of carbohydrates, and the last is x plus 2y plus z is equal to 21. The last one here is the consumption of fat. And then okay, question B, it asks here us to write in the form of AX is equal to B. So on the left hand side here is the linear system, consists of 3 equations and 3 variables. So in the form of AX plus equal to B, the A matrix A by 3 times 3, all of the constant involved, and then the second part is matrix of variable X, Y, Z, and then equal to one matrix which consists of constant 54, 62, and 21 as stated in front of you. In this part, we will learn to use the inverse matrix to solve AX is equal to B. If the number of equations in a system equals to the number of variables and the coefficient matrix has an inverse, then the system will always have a unique solution that can be found by using the inverse of the coefficient matrix. For example, AX is equal to B, so we can change it as X is equal to inverse matrix of A multiplied by B, matrix B. This can be proved by using the equations, which is we have to multiply both sides with inverse matrix of A, and then after that the multiplication of A with A inverse matrix of A, you will get the identity matrix, and then the identity matrix, if you multiply with any matrix, you will get the matrix itself. So it has been proved that X is equal to inverse matrix of A multiplied by matrix B. But please remember, take note that we can find the inverse matrix of A by using these three methods, which is adjoint method, the properties, and the elementary row operations. Let's go for example 1. Solve the following equations by using the inverse matrix method. Given to you the system of linear equations containing x1, x2 and x3 as the three variables. Then first thing to do, you have to convert the system of linear equations into the form of ax is equal to b. So from the equations given to you, change it into ax is equal to b. So you will get the form in the matrix of 3 by 3. In this section, we have to find the inverse matrix of A by using the adjoint method. First, find the determinant which we want to use in finding the inverse matrix of A. Then you will get 1 as the determinant. After that, find the adjoint matrix to use after this. Okay, you can see that we will have a 3 by 3 adjoint matrix, which is 2, -1, -2, -1, 1, 0, -2, 1 and 3. Then the inverse matrix will be 1 over determinant and then multiply by the adjoint. So you will get the inverse matrix of A. And then by using the x is equal to inverse matrix of A multiplied by B, so you can get all the variables needed in this question. Okay, which is x1 is equal to 2, x2 is equal to -1, x3 is equal to 3. Next, for the example 2, the nutritional content in gram per serving of protein, carbohydrates and fat for 3 types of cereal is given in the table below. Under a controlled diet, Nurul took exactly 454 gram protein, 620 gram carbohydrates and 21 gram of fat in a particular week. In the week, she ate X serving of cereal X, Y serving of cereal Y and Z serving of cereal Z. It is actually continuity of example before. Okay, let's see the two questions regarding here. And then question C, it asks you to verify that the inverse matrix of 2, 3, 4, 2, 3, 5, 1, 2, 1 is given to you in front. And also question D, by using the inverse matrix, solve the above system of linear equation. First, we have to verify the matrix which is given to us. Okay, so we have matrix A and also the inverse of matrix A. So how do we can verify that the inverse matrix of A is correct? So we can use the multiplication of matrix A with the inverse matrix of matrix A. So what will you get? You will get an identity matrix. Okay, let's try to do the multiplications. So you have the matrix A multiply with inverse matrix of A, and then you get the identity matrix. So that we already proved that the inverse matrix of A is correct. Okay, therefore the inverse matrix of given to you in the question is already proof. Then let's see the question D. Okay, by using the inverse matrix, solve the above system of linear equation. Given to you the system of linear equations, we have to settle it by using the x equal to inverse matrix of A multiplied by B, because we want to find the variable needed. Then we already proved that the first question, which is question C, the inverse matrix of A is correct and true, so we can use it directly and then insert into the solution. So we have to multiply the inverse matrix of A with B, and then you will get the final answer, which is x is equal to 5, y is equal to 4, and z is equal to 8. And then let's go for example 3. Okay, you have two given matrices, two given matrices, which is matrix A and matrix B. And then now we have actually a 3 question. Okay, it is important for you to read the question and understand it, and then let's see how many questions actually you have there. Now you have 3 questions actually. First, find matrix A multiply B, and then find the inverse matrix of A, and then after you get those value or matrices, and then there's hence there. Okay, hence the word hence. Okay, solve the following linear equations. Okay, there's hence there, hence word. Okay, we highlight there because this hence word means you have to use the previous answer. Okay, previous information answer to solve the next question. Okay, and then let's see how to solve. First thing first, which is first question, matrix A multiplied by matrix B. On the left hand side is matrix A, on the right hand side is matrix B. So please remember, matrix A multiply matrix B, it is not actually equal to matrix B multiplied by matrix A. So please remember, if the question asks you to matrix A multiply matrix B, so put it correctly, which is A in the left and also right on the right. Okay, so multiply and then you will get this kind of answer. This is actually if you can see, it is actually an identity matrix. If you put it outside the constant 16, so it will become 16i 100010001 with the constant 16 outside. And then okay, if matrix A multiply with matrix B, you will get 16i. So I want to change it as the inverse matrix of A as the formula. Okay, the head of the formula, and then I have to multiply both sides with inverse matrix of A, and then okay, it will become inverse matrix of A equal to 1 over 16b. Okay, please check your homework. Okay, how from AB is equal to 16i can become inverse matrix of A equal to 1 over 16b. Okay, I just give you the clue, which is you have to multiply both sides with inverse matrix, so you have to settle it down. Okay, so you become this inverse matrix of A equal to 1 over 16b, and then just multiply normally. So it is up to you. Okay, you can put the constant still outside, okay, before you multiply at the end. Okay, this is actually the inverse matrix of A value. Okay, and then we just stop right there, and then check back the system of linear equation. Okay, and then first thing first, change the system of linear equation into the ax is equal to b form. Matrix A multiply with matrix B, x is equal to matrix B. Okay, change it into this form. Then after that, the ax is equal to b. Okay, change into the form of x is equal to inverse matrix of A multiplied by B. Okay, this is already proven to you before, so please check it out. Okay, change it into the matrix form, which is x, y, and z is equal to inverse matrix of A. We already get that matrix, and also multiply with matrix B already given to you, so just insert into the equations and then multiply for both side. Okay, and then insert the 1 over 16 into the matrix 3 by 3. Okay, and then you multiply. Okay, and then you will get the matrix 11 over 8, 3 over 4, negative 3 over 8. This is actually the value of x, y, and z. Okay,